Hey guys, this is Mrs. Harbin, and this is Algebra 2, Section 5.3. So we have looked at how to multiply polynomials, we've looked at factoring polynomials, and now we're going to learn how we can solve these equations by factoring. Our biblical integration for our unit is this. We see biblical imagery of parts belonging to a whole, and this helps us to see that some numerical groupings can be broken into specific separate parts, and these parts can help us solve the whole. We know that mathematics is not in isolation, and we have to use all these individual skills, or all of these parts, to help us understand the whole. So it's not just good enough just to know how to multiply. We also need to know how to factor, and then what we're going to do today is solve by factoring. All of these parts are part of our whole understanding of mathematics. Our lesson objective for today is this. You, the student, will solve quadratic equations using the zero product property and write quadratic equations given its solution. So we're going to do two things today. We've got two verbs here. First, we're going to solve quadratic equations using factoring and this zero product property. And then we're going to then write the equations. So we'll be given the solution and have to work our way backward to that original equation. All right, our worldview connection that's coming out of this chapter, and really everything that we're doing in mathematics, really is going to be centered around this quote. So there's a quote by a Darwinian philosopher from the book titled, Can a Darwinian Be a Christian? And he writes, why should a bunch of atoms have thinking ability? If all we are, as scientists say, a bunch of atoms, what differentiates us from the atoms that make up plants or the atoms that make up rocks? Which don't have thinking ability. So why should we, as humans, a bunch of atoms, have thinking ability? And Roos continues, no one, certainly not the Darwinians as such, seems to have any answer to this. Well, Michael Roos may not be familiar with the Bible, but we do know that we do have an answer to this question. Why do we have thinking ability? And it all goes back to why we were created. Our God-given responsibility is to have dominion over creation. That means to take care of it, to rule over it, and to take care of it responsibly. And we do that. We have dominion by thinking, and by reasoning, and by discerning what is right and wrong. God gave us that ability, this bunch of atoms, this thinking ability, so that we can have dominion over His creation. The fact that we can think and we can perform mathematical operations fits into our God-given purpose. So while evolutionary scientists and others may not be able to answer why this bunch of atoms has thinking ability, we can take a look at God's Word and say, this is why. We're supposed to use this thinking ability to take care of God's creation, and math fits into that so perfectly. All right, so let's review a couple of things. First of all, we've been talking about quadratic equations through each of these lessons, and I've given you these really generic definitions, and each lesson I've given you maybe a little bit more complex definition. We are finally getting to the formal definition of a quadratic equation today. But any equation whose highest degree term is the squared term is called a quadratic equation. And I pointed that out back in 5.1, and I reminded you in 5.2. But any equation whose highest degree is that squared term, so like x squared, is called a quadratic equation. So 5x squared equals 2, for example, or 2x squared minus 4x plus 6 equals 0. Those are some examples of quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0. That's our standard form for the quadratic equation. Maybe we should write that in our notes here, that this is the standard form when it's set equal to 0 like that, where a and b and c are real numbers, and a is not equal to 0. A is not equal to 0. B could be equal to 0 and C could be equal to 0, but A is not equal to 0. When we get to graphing these quadratic equations, one other thing that you're going to know or learn is that a quadratic equation, when graphed, also is in the shape of a parabola. All right, so let's take a look at the zero product property that was mentioned in our objective here. And so this should be a reminder of some of those basic properties you learned oh so long ago. But the zero product property says that if P times Q equals 0, then either P equals 0 or Q equals 0, or they could both equal 0. Let's plug in some numbers here. So if 3 times 0 equals 0, well, either P is 0, in this case it's not, or Q is 0, in this case it is, in order for them to be 0. In order for anything in our equation to be equal to 0, one of these factors, if not both, has to be 0. So we can use that zero product property to help us solve some equations by factoring. Let's see how we're going to do that. Let's take a look at x squared plus 2x minus 24 equals 0. This is our quadratic equation. It's written in standard form. I've got my x terms in descending order from highest degree to lowest degree, and I have the whole thing set equal to 0. Setting that equation equal to 0 allows us to use the zero product property, and here's how. The first thing that we're going to do is factor our quadratic trinomial. So let's think about what are the factors of 24. That when multiplied we'll get negative 24, but when added we'll get positive 2. If you want to make that little x thing that we were making in our previous lesson, you can do that here. So negative 24 and a positive 2. Because it's a negative 24, I know one of my numbers must be negative and the other one must be positive. And I'm going to think about factors of negative 24. Well, I've got 1 and 24, 12 and 2, 8 and 3, 6 and 4, and I think I'm going to end up going with 6 and 4. I know that positive 6 and negative 4, when multiplied, equal negative 24, but when added will give me positive 2. So I'm going to rewrite that b term as the sum of my two factors there, x squared positive 6x minus 4x minus 24. And then I'm going to go ahead and factor by grouping. So I've got my x squared plus 6x and my negative 4x minus 24. I'm going to factor out the greatest common factor. In this case, x was my greatest common factor, which leaves me with x plus 6. And over here in my second group, negative 4 was my greatest common factor, which left me with x plus 6. You can see that I've got this identical binomial here, so that's one of our factors. And then the x minus 4, that's what's remaining, that's my second factor. So I've got x plus 6 and x minus 4. Now, according to my zero product property, if this is a factor, and this is a factor, and when I multiply them I get 0, then one of these factors, if not both, must be equal to 0 as well. This goes back to that p times q equals 0. If p times q equals 0, then either p is 0 or q is 0, or maybe they're both 0. So we're going to go ahead and take each of these factors and say that they're equal to 0. X plus 6 is equal to 0, or x minus 4 is equal to 0. Or maybe they both are. When we set both of those equal to 0, we're going to apply that zero product property, set each factor to 0, and then solve for the two variables. So when I solve for x over here, subtract 6 from both sides, I get x equals negative 6. And when I solve for x over here, I get x equals 4. If I were to go back up and check my equation, if I were to plug in a negative 6 here, I would find out that I would get 0 equals 0. And if I were to substitute my 4 back in, I would again get 0 equals 0. So both of those are possible zeros for this quadratic equation. When factoring quadratic polynomials, here are our steps again. First, write the equation in standard form. ax squared plus bx plus c equals 0. So our exponents are in descending order and the whole equation is set to 0. Then, factor the polynomial, using the tips and tricks that we learned in the previous lesson. After we've done that, we're going to apply the zero product property. That means we'll set each factor that contains a variable equal to 0, since we know that one of those, if not all of them, must also equal 0. We'll solve the resulting equations for our variables and end up with multiple values of x, possibilities for x. We can plug those back in to make sure that they are factors that would work. So let's go ahead and solve 3x squared plus 6 equals negative 11x. Step 1, let's write it in standard form. And when we do so, we get 3x squared plus 11x plus 6 equals 0. Step 2, think of the factors of 8 times c. That when multiplied would give us 18, but when added would give us 11. Make that lovely chart over here. We've got 18, a positive 18, and a positive 11. So I'm going to need two positive numbers here. And my factors of 18 that when multiplied, 18, and when added are 11, that gives us 9 and 2. So let's rewrite that middle b term here as a sum of our two factors, 9x and 2x. Then we will use grouping to factor out what they have in common, looking for that greatest common factor of 3x squared and 9x, and our greatest common factor on this side of 2x and 6. We get 3x times x plus 3 and 2 times x plus 3. You see that we've got identical binomials here. That's one of our factors. And our other factor is the part that we removed, the greatest common factor, 3x and 2. We'll then apply the zero product property, which says that one of these factors, must be equal to 0, since the whole thing's equal to 0. So we'll say x plus 3 equals 0 and 3x plus 2 equals 0. Our final step will be to solve the resulting equations to get the two possible values for x. And when we do that, we get x equals negative 3 or x equals negative 2/3. We could plug this back into the original equation to make sure they do actually turn our original equation back to 0. All right, let's go ahead and solve 6x squared equals 8x. Well, if I look at 6x squared and 8x, I notice that I can divide both of these by 2. I can reduce both sides by 2 proportionally. And when I do that, I get 3x squared equals 4x. Now, I don't have to do that first. If I wanted to, I could move this over and then factor the 2 out. But I'm going to actually remove this 2 beforehand, before we even put it in standard form. Once I have it in 3x squared equals 4x, I can put that in standard form. Subtracting 4 from both sides, I get 3x squared minus 4x equals 0. Notice that I don't have a constant term here, a c term. From this point, we're going to go ahead and factor. We're going to look and see if there are any greatest common factors, which there are. I have an x that can be taken out of both of these, which leaves me with 3x minus 4. My next step would be to set each of my factors to 0 using my zero product property. So I'm going to set x equal to 0 and 3x minus 4 equal to 0. And then I will solve the resulting equations. And when I do that, I get that x equals 0 or x equals 4/3. That is my two possibilities for my my 6x squared equals 8x polynomial. Do not divide both sides of a quadratic equation by x. This could accidentally eliminate a solution. So even though if we go back here, it looks like instead of dividing by 2, I could have divided by 2x. That would have removed actually my x equals 0 possibility. So I don't ever want to divide both sides by x. I can reduce it by a coefficient, but not by x. Let's write now a standard form quadratic equation whose solutions are negative 1/2 and 3. So now we're going backwards. Now we're being told what the x equals, and we're going to go backwards and put it into a quadratic equation. So we're being told that x equals negative 1/2, so we're going to write that x equals negative 1/2, and x equals 3. So let's write x equals 3. Okay, going backwards then, we're going to set both of these equal to 0. And get rid of any fractions. So getting rid of the fractions first, if we multiply both sides by 2, we get 2x equals negative 1. This side's not a fraction, so we don't need to get rid of it. Now let's set them both equal to 0. We have 2x plus 1 equals 0 and x minus 3 equals 0. Remember, we know because of our zero product property that one of these things has to equal 0. Again, we're working our way backwards. Now we know our two factors, 2x plus 1 and x minus 3. We'll then multiply these together to find our original polynomial. 2x plus 1 times x minus 3, using first outside, inside, last, or the other method, the vertical alignment method, you find out that this equation is 2x squared minus 5x minus 3. We're going to write that in standard form. So in this case, we were given the solutions. We had to set each of the solutions equal to 0 in order to get our factors, multiply those factors back out to find our original polynomial. All right, guys, we'll take a look at the rest of these examples in class. If you have any questions, be sure to write them down and ask me.